easier to search on values in the table, whether it's strings or numbers. So this makes sense. For a primary key, we are very often selecting based on ID number. So you ideally want to get back answers quickly. In the worst case, if you don't have an index, what's the running time of select going to be? Just intuitively? It's going to be big O of n, right? If there's no index, the best you can do, if it's not sorted even, is search from top to bottom and find the row that you care about. So it turns out you can do other things too. If you have a field that isn't a primary key per se, but it is going to be unique, well, you can specify it as a unique index. And we'll see this through PHP-MyAdmin's interface in just a moment. What's an example of a type of field that you might want to say is unique, but isn't necessarily your primary key? Any examples?
Email.
Yeah, email is a perfect one. So you might have a table of users who have names and IDs and email addresses. Why is email not the best primary key?
It's lengthy.
It's lengthy.
It could change.
Yeah, exactly. So it's lengthy and it could change. And by lengthy, we mean if you're just using an int as your unique identifier or even a big int where you're only using 4 or 8 bytes, whereas an email address could be many more bytes than that. So you want it to enforce uniqueness, but not necessarily be the thing that you search on. So that's a perfect example. An index is just a field that has no special properties per se, but you know you want to search on it. Now, in the context of Harvard courses, you might want to search on courses names or courses numbers or courses departments. And you don't want to go overboard. One of the tensions you'll feel is, well, I could just make everything an index and click, 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 click. But what's perhaps the intuitive downside of making everything an index? Yeah. Yeah, or not rows per se, but metadata. So adding these B trees or other data structures, you're just using bytes to expedite searches on that field. And so then, in theory, things could slow down. If you're trying to cram too much in memory, you start paging to disk, and you can't keep everything in RAM. So there's this trade-off. You should really choose your indices intelligently and not just ad hoc. And then finally, there's full text, which kind of does what it says. If you have a large chunks of text, like articles from a blog or the like, and you want to be able to do keyword searches, a full text search is optimized for exactly that, where you can do substring matching within a particular database field. All right, so let's actually see this. If I go into PHP-MyAdmin, and let's go ahead and go over to my lectures table. Actually, let's just make a new one. So let me go to my database. I'm going to say sections for a course that has sections. I don't quite know how many columns yet, so I'll do, well, actually, no, let's do users. So users, 3. All right, so a user is going to have an ID, a user is going to have an email address, and a user is going to have a name. And now we have some schema design choices. What do we want to use to identify users in a database? We don't have too many options, but so int's pretty reasonable. What's upside of an int? It's small, right? It's already selected for me, no work involved, right? So, and downsides? Yeah, absolutely. If you use something that's too small, and maybe a 32-bit int is too small if your users sometimes come and go and they add or delete their accounts or they create lots of fake accounts or the like, you could imagine using up the various ints. And even though MySQL and other database engines support auto-increment, auto-increment's purpose in life is to forge ahead in perpetuity. Even if you delete user 123, the auto-increment feature is not going to go fill in that blank in the future. Rather, you're going to have gaps in your data. And you could go back and manually condense everything, but this could break URLs that are out there on the internet. Think of Facebook URLs if you haven't chosen like a name on Facebook, but rather you just have $ID equals 12345. That's your Facebook ID. You don't really want to change users' IDs on them, nor do you want to change globally your whole database. So frankly, these days, spending 8 bytes instead of 4 per user is not all that unreasonable. And frankly, this is one of those sort of Y2K-like decisions. You might as well make the right decision now rather than have to change everything some number of months or a couple years later. So big int is reasonable, but int, not bad. If we scroll down a little bit, length and value, this is meaningless for ints. You're going to get 32 or 64 bits no matter what you put there. As an aside, if you've ever seen the number 10 or 11 in MySQL, if you recall seeing this with regard to ints, it's stupid and historical. It just refers to how many characters you can fit on the screen if you're using the command line version, the black and white window, to talk to MySQL. It formats the width of the columns. Has nothing to do with bit size. Attributes. So what should I probably choose here? Yeah, unsigned, right? Unless I'm going to actually have negative IDs, I might as well not waste 2 billion or even more, many quadrillion numbers just by allowing for negatives. Shouldn't be null. What about index? Yeah, primary makes sense. Nice and efficient, 8 bytes. And sure, I'll go ahead and do auto increment. Now, how about email? I have a few types to choose from. And let me scroll down to the ones that are germane here. There's all my string types. Which one do you want? OK, varchar y.
Okay. The variable length.
OK, so it's variable length. All right, so how long is an email address?
50 characters at most.
50? OK. So this is where you kind of should pause, right? Like, could be, but you could have crazy long email addresses. And if you don't check for those things when users register, you could end up with unanticipated consequences. What to choose? Frankly, erring on the side of too much is probably best. And frankly, I, out of sort of anal habit, tend to choose multiples of 2, but 50 is fine as well. But you might also see historically 255 was very common for years because old versions of MySQL only supported lengths up to that. You might see 65,535, which is a 16-bit value. And there's other numbers that are common. But it's up to you. All right, but what else could I have chosen? What would be the advantage of char over varchar? Yeah?
It's always 10 characters. It's filled with spaces.
Yeah, so it's always 10 or it's always 50 characters. So on the upside, that actually facilitates searching because I can actually then do random access to email addresses and I can search a table more effectively because I know what the boundaries are. And that's very useful. I don't have to search for the boundary or the equivalent of \0 if you think back to C. But the downside of using a char field as opposed to varchar? You do, right? Like if your address is like malan@me.com, like I'm wasting a lot of bytes, just null bytes, just to pad it to length 50. So for an email address, varchar is pretty reasonable. But again, these are the kinds of decisions that are perhaps non-obvious. Do you want it to be null? Well, you have to decide that for yourself if you want to allow it to be null for an email address. Probably not if the users have to register for it. Auto increment doesn't make sense. And this, we said unique before, so let's go with that. And then up here for name, what do you think? It's kind of in the same bucket as name, right? Like, I don't know. Like, let's just err on this. 128 is probably fine, give or take. Being consistent, though, now I'd probably be anal, and I'd go back and say, fine, it's going to be the same. I win. And then as for this, any indices? So maybe, right? Like if you want to facilitate searching on users' names, sort of Facebook-style autocomplete in the little search box, maybe. We would actually want to put an index on this field to search by that field. For now, we're not implementing Facebook. We just have a users table, so we won't. But that would be among the questions to ask yourself. Yeah, Carl?
So why would it be 127 as opposed to 128?
Why wouldn't it be?
Yeah.
Oh, it doesn't. Wait, why would it be?
Like you said earlier, 255, so should this be, to be consistent, shouldn't this be 127?
Oh, yeah, but then that's not a power. It's, yeah, so then I just like powers of 2. I actually don't know what the additional byte was. It was probably used for the terminator of some sort. But now, there's no terminator, at least at this boundary length. So good point. Touche. All right. But here's now another juicy question that you probably have completely ignored if you've used phpMyAdmin before. What table engine are you going to use? Now, by default, in recent versions of MySQL, you get InnoDB, which is the data, which is the format in which your data is going to be stored. If you're familiar, in the world of file systems, if you've taken 61 or 161, you might know of NTFS, HFS+, any number of other FAT32 file systems. Actually, in 50, we talked about FAT16 in the context of compact flash cards. So these are just standards that the world has decided on for storing data on disk. Database engines are just standards that the world have decided on, or MySQL in this case, for storing database data. But you get different features from some of these. So InnoDB actually offers something called transactions, which we'll see in just a moment. But you pay a little bit of a price in terms of performance. By contrast, MyISAM, which was the most popular and default for some time, you don't get transactions. You get something called locks, but you get often faster reads. So there's some trade-offs there. There's some others. The memory table actually does what it says. It makes your tables live entirely in RAM. Why would this be compelling? Yeah. It's super fast, right? You're never touching disk. It's in RAM. But what's the downside? Right, it doesn't persist, right? So this is good if you want to implement your own sort of caching engine. We'll talk later in the term about popular caching engines like Memcached, which Facebook and others tend to use. But you can implement very quick reads yourself, especially if you don't care about it persisting. There's others. Archive is essentially Archive is automatically compressed for you, and there's a whole bunch of others, both for cluster databases and other features. So for now, I'll leave it as InnoDB, but for high performance queries, there's generally a decision point to be made between InnoDB or my ISAM. All right, so what are some of those decision points? Well, this is way more data than we should care about, but this is straight from the MySQL documentation. And among my ISAM memory tables, InnoDB, Archive, and NDB, the last of which is network database, which is for clustered file systems, there are a whole bunch of different features that each of these things support, but I alluded